Thank you. I love bios that other people write for you. They always sound so good. Is it already time to version observability? Whew, I'm out of breath. I made such a rookie error. I was running late this morning. I was like, I should get in the car. I forgot I was in London. Is it already time to version observability? Spoiler alert. I think signs point to yes. For those of you who don't know me, oh, this might be a sign that our PowerPoint conversion was somewhat imperfect. We'll see. I wrote the 2 books. I work at Honeycomb, and I write about a lot of things. Phew, that one looks better. All right, every company is now a technology company. This is news to nobody in this room. But one of the implications of that is that engineering, efficiency, productivity, the way we do our work is no longer inside baseball. It actually matters to everyone. Historically, we've been kind of the artistes of the business world. Like, we don't expect to have to explain ourselves in the same, or justify our work in the same, pillars of dollars and cents, or pounds, or euros, or whatever. You just trust us. I think all that is changing, and I think this is really good. I think this is going to be good for us. It really pays to be in a high-performing team. Whenever I'm giving younger engineers advice about how to think about their careers, I always tell them, the most important thing you can do is make sure that you join a team that is good at what they do. Not just like superstar engineers, but a team that gets better every day, that learns from each other every day, that gets 0.1% better every single day, day after another. Because high-performing teams get to spend most of their time working on interesting, novel problems that move the business materially forward. Lower-performing teams get to spend their time on literally everything else. People don't own software. Individuals cannot own software. It takes a team to own a piece of code, to shepherd it throughout the years, to extend it and improve it and scale it and debug it. So how do we build high-performing teams? Obviously, we just hire all of the people we can from FANG. No, of course not. Absolutely not. In fact, there's this impression that great engineers are what build great teams, and I've always found it to be exactly the opposite. I think great teams are what forge really great engineers, because none of us is learning from zero, right? We learn starting, pooling the knowledge that's around us. How well does your team perform is not the same as saying how good are you at engineering, because your ability to ship code has a lot less to do with your personal library of data structures and algorithms, and a lot more to do with the socio-technical systems around you. If you join a team and it takes 2 days to ship a single line of code, I don't care if you're the best engineer in the world, it's going to take you 2 days to ship a line of code, right? We inherit from these structures how long it takes us to do these things, to understand our systems, et cetera. Which means that if technical leaders have one job, it's this: paying attention to the feedback loops at the heart of our systems. There are 2 kinds of feedback loops, right? There are amplifying ones, and there are leveling ones. There are ones that balance each other out and sort of return to zero, and then there are the ones that, the farther upstream you make the change, the greater the feedback loop, the more it amplifies as it rolls throughout the system. And when you think about feedback loops like deploys, code reviews, I think, we can get really distracted with all of the symptoms of, of teams that have, lost their way. But I think that if there is a golden key to team performance, it really consists of that small interval between when you write your code and when it's live. I think I'm getting ahead of myself a little. When I think about modern software development practices, though, I really come back to these things. Putting engineers on call for their own code. Again, it's a feedback loop, right? Practicing observability-driven development. TDD is great, but it stops at the border of your laptop. TDD is never going to tell you if your code works or not. It's going to tell you at best whether or not it's logically correct, probably. Testing in production. Everybody tests in production. Only some of us admit it. And if you don't admit it, you're probably not investing enough engineering cycles into doing it well. Separating deploys from releases using feature flags, I think, is one of these stealth things that makes such a difference in continuous deployment, or at least continuous delivery. What do all of these things have in common? They're all about fast feedback loops. Getting your code into production as fast as you can. Because when it comes to software, speed is safety. As human beings, as embodied physical creatures, we have this tendency when we get anxious or scared or nervous to freeze. We slow down. We try to get control. And that doesn't work with software. You know, I don't remember who said it. One of my favorite quotes is, you can either have better software faster or worse software slower. It's like riding a bike or ice skating. You slow down too much, you fall over. Blinkety blink. So, getting code into production fast is the key feedback loop that everything else proceeds from. Because that moment of time, you know, when you just shipped something that you just wrote, you have everything in your head. You know why you built it, what you built, how you built it, what you tried that worked, what you tried that didn't work, what the variables are called, what the functions are named, what API calls it makes. And if you close the loop, if you're instrumenting your code as you write it, you deploy it, and you go and you look at it through the lens of the instrumentation you just wrote, and you ask yourself, is it doing what I expected to do? And does anything else look weird? Technical term. That is your best chance to catch anything that's wrong with it. Because how long does this last? I don't know, hours, maybe? I don't know. It doesn't survive paging in and out another project, at least not for me. Maybe some of you are different. But if I've picked up another project and put that one aside, it's gone. And you can't get it back. No one will ever know that code as well as you know it in that beautiful moment. And so closing that loop, that's a big part of why this is so true. That the cost of finding and fixing bugs goes up exponentially from the moment that you write them. This was research that Facebook did. You type a bug, you backspace, good for you. You catch it with your tests, excellent. You catch it in production, after that, who's going to find it? Probably not you. Probably a customer, somebody else, weeks, months, years down the line, maybe it will never get found. That window of time is so precious. And your ability to do it is grounded in the quality of your observability. But what does that even mean these days? There have been a lot of definitions bandied about for observability, and I am probably responsible for more than my fair share. When Christine and I started Honeycomb back in 2016, observability wasn't really a thing in the industry. And in fact, we reached for it as a way to try to describe what we were building and how it was different from monitoring. And I remember so clearly, like July of 2016, when I Googled observability and I read the definition from Wikipedia. In control theory, it's basically, it refers to how well can you understand the internals of your system, any system state, just by observing its outputs. And we were like, oh, that's absolutely what we're trying to do. And so over the next few years, we developed a laundry list of a technical definition. You have observability if you have high cardinality, high dimensionality, explorability, blah, 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 all this stuff. Not very easy to understand. And then around 2018, Peter Borgon wrote the famous blog post about 3 pillars. Observability has 3 pillars. And around 2019, 2020, all the other vendors kind of went, we do observability too. And to us, it means 3 pillars. Because purely coincidentally, I'm sure, they have metrics, logging, and tracing products to sell. In 2022, Gartner added APM observability to the Magic Quadrant and used our technical definition for observability. But these days, it's a muddle. What does it even mean? Is it about known unknowns versus unknown unknowns? Is it about, what is it? So I would like to propose one more definition, which I really like these days, which is that observability is a property of complex systems. just like performance, reliability, just like any other performance. What I like about this is that it shifts the focus from a laundry list of features or tools or whatever to the consequences, to the systems that we're observing, which means that if you have a system and you need to improve its observability, adding metrics improves its observability. Adding some logs, structuring your logs, teaching your coworker to use some of the dashboards that you use. All of these improve your observability. In some systems, adding dashboards might improve your observability, and in others, deleting dashboards might improve your observability. So I like this, but it kind of leaves us begging the question of how to describe, the problem that was formerly known as monitoring versus observability, and that these days I would characterize more as just the enormous, discontinuous step function and value that engineers are experiencing when they move from 3-pillarsy type tools to more modern tools. And this is why I am going for the most cliched thing in all of technical marketing, which is a version upgrade. But I think it's justified because according to semantic versioning, when do we bump the major version? It's for breaking backwards incompatible changes. And I believe that this is what it is, because for 1.0, it's the 3 pillars land. You've got your metrics, logs, and traces. You've got your APM tools. You've got your RUM tools. You've got your dashboards. You've got your logs. You've got your systems logs. You've got your application logs. You've got your tracing tools. You've got your profiling tools. You've got all these different tools. And what connects them? Nothing. Nothing but the engineer who sits in the middle going, I'm going to copy-paste this ID from my log tool to my trace tool. I'm going to eyeball that shape on that dashboard against that shape on that dashboard or that logging over there. Nothing connects them. You've got many sources of truth, and they don't always agree. 2.0 has a single source of truth, arbitrarily wide, structured data blobs. You can call them structured logs if you want. You can call them events if you want. They have IDs so that you can visualize them over time, or you can slice and dice them. You can treat them just like data. From this data, you can derive metrics, you can derive logs, you can derive traces, you can derive your SLOs. But because they share that connective tissue, you don't have to guess, and you don't have to jump around, and you don't have to pay again and again and again and again and again for tools that, quite frankly, as the cost goes up and up, the value that you're getting out of them goes down and down. We're going to dig into this in a bit more detail, sort of a snapshot. Observability 1.0. Bunch of data formats captured separately, static dashboards, and because there's no connective tissue, a lot of your debugging consists of intuition, guesswork, the scar tissue of past outages. 2.0 is wide structured logs, and the interface is exploratory. It's about forming hypotheses, behaving more like a scientist than pattern matcher. This was the former definition of observability, and I think it's much clearer to just be like, if you have 3 pillars and many tools, you're in observability 1.0 land, and if you have a single source of truth, you're in 2.0 land. Now, this is it's kind of remarkable to me just how many complex socio-technical phenomena can emerge from just the way that we lay bits down on disk. So it gets kind of complicated, and I'm not trying to pretend that these are like on opposite sides of the room. Obviously, there's some overlap. So let's dig into this a little bit more. How the data gets stored, siloed tools versus it's just data. With Observability 1.0 tools, you typically do all of your aggregation at write time, because time series databases retain no relational data whatsoever. So you have to write out every single combination of metrics that you want to store. And in 2.0, it's just data. Under the hood, there are only 3 types of data, right? There's the metric, there's unstructured logs, strings, and there's structured logs. The predominant format of Ollie 1.0 tools is metrics-based stuff. RUM tools built on metrics, APM tools built on metrics. And when we talk about metrics, there's 2 ways that we use this word. There's the generic noun metrics, which just means telemetry. And then there's the big M metrics, which is a specific data type, which is a number. with tags appended. It's just a number, and it's stored in a time series database without any relational data except for the time. Every metric is a single number, some tags appended, sort of TSDBs, and I know I'm like underlining this a few times, but the limitations are real. Like, there are a lot of really powerful use cases for metrics. Efficiently summarizing vast quantities of data, great for metrics. Letting you age out data gracefully while degrading, the granularity while retaining the overall shapes, great for metrics. But like, trying to understand your software and the relationships between events that are happening, terrible tool, terrible. It doesn't work. Which is why, to understand our systems, we increasingly turn to logs. This is the UK, so I can say that, right? Even unstructured logs are more powerful than metrics because they preserve some of the context and connectiveness. However, you have to know what you're looking for in order to find it, which is kind of a characteristic that's true of all observability 1.0 stuff. And again, the only thing you can do is string search, which is slow. And the more data you have, the more you're paying, the slower it gets, the worse the experience. One of the other really interesting things about 1.0 versus 2.0, I think, is that observability 1.0 was very much about operating software. MTTR, MTTD, reliability, postmortems, it's something that you make sure that you're monitoring your code before you ship it to production. And observability 2.0 is not just about errors. It's not just about problems. It's about understanding your software. In a very real way, it's what underpins your entire software development lifecycle. It's what allows you to hook up these feedback loops and make them tight and move swiftly with confidence. There's so much, I think of like dark matter in software engineering, where it's just like, why is this so slow? Why does this take us so long? Like, there's no apparent reason, but everything is just hard. And so much of that, I think, can be traced back to the fact that our tools have had, the connective tissue is not there. So we have to guess. We have to have a mental model in our heads that we could reason about, that we can form hypotheses about. We have to, try to debug our code by reading it. It's insane. No wonder it's so hard. No wonder it's so slow. There are so many reasons to want to go and explore and understand your software that have nothing to do with getting an error or having an outage. Anytime you want to understand what a user is doing, anytime you want to understand if what you've built is having the business impact that you want, anytime you ship some code, you should want to understand if it's working or not before you move on. Observability 2.0 is about how you develop software. How you interact with production. This shifts a lot too. I think in observability 1.0 land, it's, there's a stereotypical, my test pass, I'm gone for the day, and then you wait to get paged. Surely none of us do that anymore, but still, I feel like there's a trade-off, right? Once upon a time, you could not look at production unless it was telling you that you needed to look at it. In fact, so I come from operations, and there was once upon a time when we considered this a best practice, that your systems will tell you when you need to look at it, and you shouldn't have to watch them all the time. And that made kind of a certain amount of sense back when the problem was that we needed to automate things, right? And so you shouldn't be staring at dashboards all day. The system should let you know when you need to look at it. But it's a very different model when you're trying to use production to validate that what you've developed is correct. And so when you go from Ollie 1.0 to 2.0, typically, and this is one of the most exciting things, you get to delete 90 to 95% of your paging alerts because you go from having paging on symptoms to paging only on SLO burndowns, which is amazing, right? It aligns your engineering pain with your customer pain. You should never wake an engineer up unless your customer's in pain. And SLO alerts don't go off nearly as often as symptom alerts do because they're not as flappy. So now you're looking at production like 1/10 or one tiny fraction percent as much as you used to. So in exchange for that, you you change your workflow to include looking at production as part of shipping code. And this is something where I feel like observability-driven development, this process of closing the loop by looking at production, as you're developing your code, there's going to be better tools for this in a couple of years. I feel like we're in the very early days of this. We're kind of where TDD was like, 10, 15 years ago when everything was pretty manual. And I understand why the tooling doesn't exist yet, because you can't really build that kind of tooling until you have a substrate of observability 2.0 tooling, because with 1.0, you're dealing with aggregates and exemplars. You aren't able to actually slice and dice and look to specific raw events and compare them like with a scalpel, right? Like I flipped a flag and I shipped this diff to this canary, and so I went to graph side by side what exactly was the change for these exact events. Right, when you have that level of specificity, and you can look at your code at that level, then having tooling on top of that to wrap that into your development cycle is really meaningful. But right now, it's manual. It's early days. How you debug. We talked about this a little bit, but in Observability 1.0, there's a lot of dashboard flipping, a lot of just eyeballing, scanning, just that shape looks a lot like that shape. They're probably related. Because, again, with metrics, you discarded all that connective tissue when you wrote out those two different metrics. So you have no way of validating after the fact whether or not those actually refer to the same event. A really unfortunate side effect of this is that in Observability 1.0 land, the best debuggers are always the people who have been there the longest. Because debugging relies on so much guessing, intuition, knowledge, experience of past outages. So much of it is just I used to be this guy, and I loved being this guy. You feel like a god, right? It's I see the wall of dashboards. I know it doesn't say Redis anywhere there, but I know it's Redis. Go and look, I'll wait, and you just feel, you feel like a king. Because you're right, and nobody else can figure that out because the data doesn't exist, but it feels so good. Then you get paged at 3 a.m. on your honeymoon, and suddenly it doesn't feel so good anymore. But I feel like we've started to accept this as just a fact of working on systems, and it's not. I've now worked on multiple teams where they're using Observability 2.0 tooling, and the best debuggers are the people who are the most curious. The ones who have a habit of checking their code, the ones who have that sort of visceral gut feeling that they're not done until they've validated it in production. Because when the data's there, it has this very democratizing effect when everyone has access to it, because it doesn't rely on everybody's private mental models to understand. That last one is something that our designers are spending a lot of time thinking about right now, because in Observability 1.0, our debugging style was very search first. You had to know a string to search for or a dashboard to jump to. Everybody's got their personal library of bookmarks that they use as touch points into the system. And with Observability 2.0, and I think it's no accident that this often happens when you reach a certain cliff of complexity, but you don't need to know what you're looking for in order to start debugging. You typically start from an SLO burn down or just that looks weird, because so much of debugging comes down to, here's the thing I care about, now tell me why I care about it, right? Because you want to know, how is this thing I care about different from all of the things that I don't care about, which is something that you don't need AI to tell you. All you need is connective tissue in your events and a lot of computation. The cost model, oh my God. So I wrote a blog post about this, so I'm not going to go into this super deeply. I wrote a blog post earlier, and I think, what day is it? I wrote a white paper, I think it went out yesterday, that went more deeply into the cost model of metrics specifically. Ever since I wrote the first blog post, I've been hearing from observability engineering teams who are we spend the outright majority of our time now on cost control. Not writing libraries or adding value to the org, but on trying to manage costs. And after writing that white paper, I now understand why. When you hear the word custom metric, what do you think? I think a line of instrumentation. That sounds like a custom metric to me. And so with most metrics providers, you get a couple hundred free custom metrics. That sounds great, except that's not what custom metric means. Custom metric refers to the number of unique time series that your thing is generating. So in my white paper, I computed out the cost of just capturing request.latency. And if you capture request.latency for 1,000 nodes, for 5 handlers, 20 endpoints, and 63 status codes, it costs you $63,000 a month. One metric. It's absurd. Now, anyone who knows metrics is going to be like, well, that's not how we do it. We would never capture all 63 status codes. We would bucket them into 5, 1x, 2x. Of course, there are lots of hacks and workarounds, but like, that worked really well when our systems failed in mostly predictable ways. Nowadays, it's really meaningful to me whether or not this is a 502 or a 504. You know how many times I debugged some wacky-ass problem just by a weird status code and a string somewhere? Like, all of this data, all of the data that is valuable to you is high cardinality data. And metrics cannot support high cardinality data, like by definition. So why observability costs so much is because you have to pay for so many different tools. I'm conscious of time here. Everyone has a multiplier, right? If you're paying for 5 tools, 7 tools, then your costs are rising 5x or 7x as fast as your traffic is. And so many of them are built in metrics. And I think that the greatest costs of all are the ones that we just can't see because we can't see the connection between what's happening. Oh, cool. I put my envelope math in here. There you go. 63,000. I don't mean to pick on Datadog. It's just that they're the leader, so they get picked on. It's not their fault. Like, people are like, they're out to soak us. They're not. They're honestly not. Metrics are a really powerful tool for the job of summarizing vast quantities of data. They're not built for relational data. They're not built for trying to understand the combinatorial, every possible combination of hosts and methods and handlers and status codes. That's just not the right tool for the job. And there's been a lot of angst about the cost of observability lately. And you know what? Observability 2.0 isn't cheap either. Good telemetry will never be cheap. The bigger problem is that with observability 1.0, you run into this anytime you have a data problem, right? Where the tool you're using for the job is not the right one for the data model. You just run into a place where, as your costs go up, the value that you're getting out of them goes down. And that's a really sad place to be. Something I hear a lot is, ooh, this sounds great, but we're still trying to master 1.0. 2.0 sounds great, but maybe in a couple years. And this is where I just want to wring people's necks, because the way you're doing it now is the hard way. It's so fucking hard. Sorry. It's so hard dealing with metrics and unstructured logs. It's so costly. It's so complicated. Trying to wrap your problems into weird combination of metrics you can do math with and tags that you can search, but never the twain shall meet. It's so complicated. We've spent decades now learning how to deal with this, but if you set it in front of a new grad, 2.0, they pick it up so much faster because it's just data. It's just data. We've learned to be super clever about this, but what if we didn't? What if it was just data? So I feel like metrics are inarguably the bridge to the past. I feel like structured logs are the bridge to the future. Any team that is wanting to start building toward, there's a bunch of stuff that I think goes into Ollie 2.0, like having columnar storage and explorable interface and everything. But you can have your team start today by adopting open telemetry, by taking the investment of time and energy that you're pouring into your metrics back tools, and at least pour them into your structured log back tools. That is effort that will pay off for you. Just to compare, with structured logs, you should be able to capture every single one of these dimensions, and then just slice and dice, break down, group by, treat it like data. You build better systems, and you become a better engineer building this way. I firmly believe this to be true. When you have a hypothesis in your head and you ask a question, based on the result, you ask another question. You follow the trail of breadcrumbs to the answer every time. I keep getting ahead of my slides. Instrumenting your code according to the principles of canonical logs is super important, which means basically the costs of logging right now are mostly bound up in the fact that we tend to log, just like log a whole bunch of lines for every request. And what you want to do instead is like initialize an empty log event at when the request enters the service, pre-populate it with anything you know about language internals, systems, whatever, parameters, and then as it's executing, you just append stuff to the blob, right? Shopping cart ID, user ID, whatever. And then when the request is ready to exit or error, you ship it off to your storage as one arbitrarily wide structured data blob. What's brilliant about that is you can have as many custom metrics as you want for free because you just make the lines wider and wider. And the wider they get, the more powerful your ability to debug because all that context is bound together. You're able to pick out outliers, rare things that happen, rare combinations of events, just like, oh, this thing I care about is different from everything else in that, oh, this little dip here, it's for Android devices, using this version, using this build ID, using this language pack, using this blah, 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 blah. Like the wider your events get, the better off you are. I am almost done, I promise. What got us here won't get us there. We used to be able to keep it all in our heads. But increasingly, our systems can't be brute forced. There was a time when we could brag about sleeping under our desks and just throwing down and crushing code and shit. And it, seemed like a good idea at the time, maybe. It wasn't. Increasingly, our systems are so complex that you need people to be well-rested. You need them to be emotionally engaged in their work. You need them to care. You need their creativity fueled, right? You need them to feel like part of a team. We can't brute force the problems that are in front of us increasingly. Writing code is not the hard part. It never has been, and it never will be. And I know I say this as someone coming from operations, but it's still true. Writing code is the easy part, and everything that we're seeing with generative AI, it's cool, but it's like, how did my coworker put it? It's like having a really excited junior engineer who types really fast. It's cool, but the work of the software hasn't been done yet. The work of software is making it maintainable, making it intuitive, making it manageable, scaling it, all of that other work. We can't just hold it in our heads anymore. Those of us who try will be outcompeted by those who get better tools. Observability 2.0 is fundamentally a way to advance the craft of software engineering, which is a way to make it easier and faster and safer to bring change to the world. The biggest obstacle between us and a better future is that we don't believe that it can be done. And I take your point. I am a vendor. So you shouldn't just trust me. But we've just been told, oh, we can't have high cardinality. And we accept that. There are so many talks and books and blog posts about how to avoid having high cardinality data when high cardinality data is the data that you need to understand your systems. More is possible, and we need to hold our vendors to a higher standard. So in conclusion, are we too busy to improve? Thanks.